Hi, welcome. My name's Michael, and I just had a cup of coffee, but I'm still tired, so I'm taking a study break, and let's solve this LeetCode question. So first of all, I really hope you and your family are safe during this pandemic, and do all the good stuff, take all the precautions, wash your hands, don't touch your face, and hopefully this would be over soon. So we should subtract the product and sum of all the digits in an integer and put that together. Actually, this is a really simple question. The only hard part to this question actually is not that hard. Like, the only thing you need to know is how to extract all the digits in an integer individually, and let's do that. So you could naively just convert the integer to a string and then get all the characters in that string and convert each and every character in that string to an integer, but that is really messy, and your time complexity goes way up when you have very large numbers and you have to convert that large number to a string and loop through all the characters in that string. It's just messy. Don't ever do that. One way you could extract all the characters numbers, all the single numbers in an integer, is by using the modulus operator. So how does this work? Let's say we have the number 234, that's 234, and you want to get the number 4. What you do is 234 modulus 10, and this gives you the remainder, which is 4, and 4 is the last digit in 234. And then you want to get 3, so now that you have 4, you do 23 modulus 10, and that gives you 3, which is the second to last digit, and you do 2 modulus 10, which gives you 2, and now you have 2, 3, 4 separately. So that's exactly what we're going to do. It's going to be clear as we go through the code, and let's just dive right into it. So I'm going to write a function to get the product of all the digits in the integer. I'm just going to call this getProduct. Very literal. And now the coffee makes me really trembly, so I might mistype some words, but it's just fine. And so as we said, what we have to do is we have to go through the number and extract the last characters of every number. So let's start with an initial product. We initialize that to 1, and we know that every number multiplied by 1 is the number itself, so this would not change if we do like n multiplied by 1, which is like 234 multiplied by 1 is still 234. Okay, enough ranting. So we do while n is greater than or equal to 1. You'll get why we're doing this in a bit. So we're looping through the number, and every time we get the last digit in the number, we reset the value of that number. So when we're at 234, we get the last digit, which is 4, and then we reset the value of 234 to 23. So how do you reset the value of 234 to 23? Well, you just divide by 10. Awesome. So now we want to get the last digit of this number. So let's just call it and last digit, and that would be n modulus 10, and that's the last digit. And then we want to multiply that last digit by the current product that we have. So we say product is equal to product multiplied by the last digit. And that's last digit. It's quite it. And now we want to reset the value of n. So now n is equal to n over 10. And that's going to reset the value of n. So after everything, all we have to do now is just return product. And this is going to give us a product of all the values in all the single numbers in this digit, all the single digits in this number. Can't say it right. And now we write another function to give us the is it sum? Yeah, to give us a sum of all the digits in this number. We are going to write a public int. I'm just going to call it get sum. Again, very literal. And that's n. It's going to be very identical to this. The only thing is the sum we're initializing is going to be 0. Because if we initialize a sum to 1, we are going to get a sum that is 1 more than the original sum of all the digits in the number, and we don't want that. So if you do 0 plus 234, you get 234, because that's the way math works. All right, so we're going to do while n is less than or equal to 1. We get the last digit. I feel like we could put this to function in the same, this function, we could put all the computations here in this function, but it's 12 a.m. and I'm really not feeling like it, and this looks really self-explanatory. So for clarity, I'm going to leave it like this. It really would not affect the time complexity by much, I don't think. And modulus 10, and that's getting the last digit, and we just do the sum plus equal to last digit, which is sum equals sum plus last digit. Awesome. So at the end of this, what we have to do now is reset the value of n, and that is n is equal to n multiplied divided by 10. And then we reset the value of 10. All we have to do now is return sum. And that's pretty much it. So why are we doing while n is greater than or equal to 1? Going back to our conceptual overview. So when we're at 2, 3, 4, right, we modulus by 10, and then we get 4, and then we reset to 23. But 23 is greater than 1, so the loop is still going to run, and then we get to 2, and then we modulus by 10, and that gives us 2, and 2 is still greater than 1, and then we reset the value of 2. When we get to 2, we have to reset the value of 2. So here we're doing 2 divided by 10, and that's going to give us something around 0.2, I think. And that's really not part of the number anymore. We are way, way out of bounds, and we don't want to do that. So we only reset the value of the number if the current value is greater than or equal to 1. Come to think of it, if the number is 0, then sum's going to be 0. The number's 0, then product's also going to be 0. So we don't want to go below that. I feel like I could have said that better, but I mean, I think you understand. Now we have to do just one thing, and this is where all the magic happens. We return, is it the product minus the sum? Yes, so we return get product of n minus get sum of n. And that is pretty much it. Run this code. Awesome. I solved it some minutes ago, probably like an hour. Oh, 36 minutes ago. Awesome. Cool, cool, cool. And it's really, really fast, even though we're doing 2 while loops when we could have just done one of them. So let's dive into the time and space complexity of this algorithm. So time complexity is O of D, where D is the number of digits in the integer, and space complexity is O of 1, because we're not storing anything. Let me check. Double check. Are we storing anything? No, we're not storing anything. So space complexity is going to be O of 1. So let's try to get the product and sum of these two numbers. Oh my god. Let's try to get the product and the sum of all the digits in the integer in one loop. So we get the last digit, we get the product. I think right around here we need to get the sum, which is going to be, let's try to int sum, initialize it to 0. And what we have to do now is sum plus equals this guy right here, last digit. Come on. Okay. Now we have the sum, now we have the product. I mean, right off the bat here, we could just do return product minus sum. Already have that. And get this guy and put it in here. It's pretty much the same thing. And now we get rid of this. So if you were in an interview setting and the interviewer was really being, I don't know, feeling himself that day and says, okay, so how do you make these lines of code much more shorter? How do you do this in less lines of code? You would do this, even though it's a little less self-explanatory. So we get the product, get the sum, and we subtract it, multiply it, whatever, and run this, yeah. Okay, it has a T. Okay, submit. It should run in the same time and space complexity, right? And that really did not affect the time complexity by that much. It's still faster than all the submissions for Java. Anyways, I feel like I'm waking up now, so I gotta do some algorithms and data structures and some studies. So if you're wondering if you'd ever have to use these algorithms in real world situations, like on the job, I'd say yes. And one example is I had the same problem yesterday. I've been working on some augmented reality applications for some school project with some big aeronautics agency. And what you have to do in that project, well, the particular case study was you have to move through a set of screens, and the system is completely controlled by non-conventional inputs. And for us, we're using like gestures and voice commands and stuff like that. So, right, so we don't use like typed inputs and like remote controlled inputs, so you really have to do gestures. So my gesture function, what it does is it counts the number of instances of a gesture. So if you do a certain gesture, it counts it over and over again. It doesn't count it just once. So if you want to move through like a number of screens and you just count the gesture instance and move to the next screen, what you're going to do is you're going to move through all the screens very, very fast. Because what it does is it counts the gestures in like a millisecond or something, like gesture, right? So if you want to minimize the way the count is done so you can move through screens, what I did was I just got the count after a certain amount of time, a certain interval of time, and then divide by 10 and get a much more smaller number. So these things come up in the on the job type of scenarios, and yeah, so that was a lot of ranting. I hope you like this type of content. I'll try to solve harder questions, maybe. Anyways, like this video and all the good stuff. Share it with your friends and family who might be preparing for their coding interviews, and comment down below. Let me know if you think there are ways we could have made this work better, and I'll see you in the next solution. Bye bye.